This is the official metric for 1 second. Since 1967, our global timekeeping has been anchored to 9,192,631,770 specific oscillations of the cesium-133 atom. This single number acts as the invisible skeleton for nearly all modern infrastructure. It allows GPS satellites to triangulate our position and keeps global financial exchanges synchronized across every time zone. Producing this level of stability requires specialized, highly shielded instruments designed to isolate a single atomic transition from the chaotic vibration of the natural world. That same mechanical precision is the bedrock of experimental physics, allowing researchers at CERN to track the decay of particles that exist for only a billionth of a human standard second. Because this tool is so reliable, we often treat the second as a physical law. But these instruments are engineering choices, not discoveries of an underlying universal clock. The ODTOE framework suggests that this metrological reliance on cesium-133 is a convention. The atom itself possesses no special status in the universe. We have mistaken a high-performance stopwatch for a definition of reality. There is a distinction between keeping time stable and understanding what time is. We selected cesium because its frequency aligns with our own biological scales. We can count these cycles because they occur within a specific perceptual window we are evolved to register. Our universal clock is actually a mirror. It is a system built to function at the same frame rate as the human observer. All measurements of duration require an observer. To say something took 10 seconds requires an entity capable of registering the moment a process begins and the moment it concludes. Cesium clocks are effective for us because the atom's transition speed is fast enough to provide precision, but slow enough that we can group billions of those cycles into a single perceivable unit. This chart labels the coherence cycle, the bandwidth BOC, where an observer resolves events sequentially. For an observer 1,000,000 times faster, the window shifts right, making the cesium tick appear static. For a slower observer, it shifts left, compressing oscillations into unresolved noise. Under the ODTOE model, time is not an external dimension flowing past us. It is the specific rate at which a self-referential observer can resolve their own internal coherence. This means a second is not a universal constant of space. It is a measurement that only takes shape when it is indexed to the specific resolution of an entity watching it. This shift in perspective reinterprets how we view gravity. General relativity shows us that clocks physically slow down as they approach the immense gravitational pull of a black hole. The standard explanation is that the fabric of space-time itself is warping, causing the flow of time to drag. ODTOE proposes that the local gravitational curvature is not bending time, but is instead physically modulating the frequency of the observer's own coherence cycle. This modulation happens within the configuration field, or field H. Gravity alters the geometry of this field, which in turn shifts the rate at which any physical observer inside it can process events. This link between field geometry and observer coherence explains directional asymmetries observed in astrophysics, specific anomalies in how objects rotate or decay that standard general relativity doesn't account for, but that become logical if the field itself has a specific twist or chirality. In this model, time dilation isn't a breakdown of reality. Is a predictable shift in an observer's frame rate as they move through different curvatures of the configuration field. This leads to 3 major shifts in our understanding. First, the idea of an absolute frequency is gone. Our atomic standards are local engineering choices, not universal truths. A civilization with a different biological coherence would naturally anchor their science to a completely different physical oscillator. Second, our own biological sense of duration is not a messy approximation of a truer atomic clock. That biological timing is the primary reality. It is a precise physical state uniquely indexed to the observer experiencing it. Third, the strange behavior of time at near light speeds or in extreme superfluid states is not evidence of time breaking. These are signatures of the coherence field's geometry directly influencing how the observer is configured. Metrology gives us a human baseline, but across the universe, there are as many valid versions of a second as there are observers to measure them. This doesn't mean we should throw away our atomic clocks. The framework doesn't disrupt the math required for practical engineering. Cesium-133 remains the most stable convention for human-scale life, allowing our technology and our civilizations to remain in sync. But we must acknowledge that a convention is not a foundation. A useful tool for measuring a human day is not the same as a master law of the cosmos. The universe has no single overarching rhythm. It only ticks at the speed your own biology allows you to witness.